Today we are going to take the topic permutations, and it is permutation, as you all know, it is nothing but the arrangement of things. The total topic is permutations and combinations. Briefly, I'll tell you the difference between a permutation and a combination. In a permutation, you will have the order of things to be considered. In a combination, the order of things not to be considered. So, how to apply permutation in a problem and where to apply a combination in a problem, that's what your understanding must be in working out the problems. So, your approach in solving the problem will be improved if you understand the practical meaning of a permutation or a combination. Like wherever the order of things is to be considered, therever you have to apply a permutation. Wherever the order of things is not to be considered, then you have to apply a combination. For example, if you take 1, 2, 3, if you take 1, 2, 3, 1, 2, 3 is a digital arrangement. The digital arrangement here, 2, 1, 3 is different from 1, 2, 3. Here, 3, 1, 2 is different from this one. So, in this case, because all these are different, then you have to apply a permutation. That's a brief understanding about a permutation. And a combination, if you take a team, in a team, if you have 11 cricket players, let me say, in these 11 cricket players, 1, 2, 3, 4, so on, 11 members will be there in the team. Then in such a case, to play the cricket, whoever is in the beginning, whoever is in the ending, whoever is in the middle, we are not worried about that. We need the number of members to be 11, that's all. So their order of arrangement is not needed for us to play the cricket in this case, to play the game in this case. So in this case, generally, we make use of a combination. So because the order of things is not to be considered. Similarly, then you may think in this way. So always for this type of digital arrangements, we have to make use of permutation only. Then I don't say like that also, because these digital arrangements can also be asked as a combination. Like what? I'll explain you that. So, for example, I will write the internal arrangement of all this. This is 1, 3, 2. This is 2, 1, 3. This is 2, 3, 1. This is 3, 1, 2. This is 3, 2, 1. Like this. How many you have got here? Totally, you have got 6 here. So, this is 1, 2, 3 is arranged in 6 different types. So, how many ways these 3 are arranged here? These 3 are arranged in 3 factorial different ways. What is 3 factorial? 6. 6 different ways these are arranged. So, if you want to make it a combination in such a case, simply we can alter the question like this. Find the number of digital arrangements. Number of digital arrangements taken from the digits are chosen from 1, 2, 3, 4, taken from or chosen from the digits 1, 2, 3, 4, such that the digits are in the ascending order of magnitude. Digits are ascending order of magnitude means this is an ascending order of magnitude. This is considered, and this is not. So with a small addition in the question will be converted to a combination. So you must be aware of the questions first. While reading the questions, you must understand that whether the order of things is to be considered or not to be considered is very important in a permutation and a combination. And if you see the formula for permutation, I don't want to derive the formula because you all know, you already given in your board examination all these things you have learnt and you already given your board examination. So you are all aware of all these formulae. P of n comma r is nothing but n factorial upon n minus r factorial. This is a formula. Now, what makes the difference between a permutation and a combination? If you want a combination, C of n comma r. C of n comma r is nothing but P of n comma r divided by r factorial. C of n comma r is nothing but P of n comma r divided by r factorial. What is this r factorial here? R factorial, the permutation is to be divided with r factorial because the order of things chosen is not necessary for a combination, and hence the permutations if divided with r factorial will give you the combination. So simply it is n factorial upon r factorial into n minus r factorial will give you NCR, please. This is a formula for NCR. The relation between these two is this one. So when you multiply combination with r factorial, that means P of n comma r is, or otherwise in your regular style, NPR is equal to r factorial into NCR. NPR is equal to r factorial into NCR will give you the relation between these two. Okay, so whenever the problem arises, and there itself I'll discuss more about this. Okay, so this is briefly about a permutation and a combination. What is it exactly? Permutation is nothing but the arrangement of things or objects by taking sum means SYM, sum or all at a time. That means when you have some students of 50 students are there in a class, and if you want to take some 12 students from the class, and if you want to arrange them separately in separate chairs, then in such a case you have to apply a permutation but not a combination, because you have to arrange the students in that case. Similarly, you can take 12 students from 50 students, or you can take 20 students from 50 students, you can take 40 students from 50 students, you can take all the students from 50 students. That is 50 students from 50 students. So the permutations are nothing but the arrangement of things by taking sum means some of them. That's, for example, from 50 we take 12 or 20 or 35, like that. Sum or all means 50, all the 50, all at a time is nothing but a permutation. The important thing to be remembered is in a permutation, the order of things is to be considered. And what about a combination? If you want to form a committee of 5 students from 50 students, if you want to form a committee of 5 students from 50 students, you don't apply a permutation. In that case, you have to apply a combination. Because in a committee, we don't need their order. There we are particular about their number. Number is the required number in this case, what I mentioned, is only 5. In such a case, you have to apply a combination. So permutation is nothing but arrangements of things in which order of things is to be considered. Combination is the selection of things in which the order of things is not to be considered. That's briefly about that. Now let's go through the problems, and while discussing the problems itself, we will go through the theoretical points. Okay, let's see the first problem in this one. See the first problem there, the slide. The first problem, the number of positive terms in the sequence xn is equal to 195 divided by 4 into n factorial minus n plus 3 p3 divided by n plus 1 factorial. We need the number of positive terms in this one. You need the number of positive terms in this one. This is xn. It is a series. It is a series. N may take values from 0, 1, 2, 3, something like that. If it is a series, then there are some restrictions for n here according to this, because the factorials are defined only for the positive, only for factorial is defined only from 0. And in this case, n plus 1 should be greater than or equal to 0. In this case also, n plus 3 should be greater than 0. So there are some restrictions in the beginning itself whenever this is given. So here, n plus 3 is greater than 0 because it is in the prefix, and the denominator n plus 1 should be greater than or equal to 0, because 0 factorial becomes 1 only. Not a problem, not a problem. So common value for these two is nothing but n is greater than or equal to minus 1. N greater than or equal to n greater than minus 3, n greater than or equal to minus 1. Common values n greater than or equal to minus 1 is the common value for these two. Okay. Now keep this into consideration. Now we will find out the positive terms, the number of positive terms in the sequence. We require the number of positive terms in the sequence. So now let me keep this in consideration and let me simplify this. Now xn is nothing but 195 into LCM n plus 1 minus n plus 3 p3. Let us write this at a place, and we will take this and we will simplify this. What is the result we have got here? N is greater than or equal to minus 1. Now let me simplify this first for your better understanding. 195 divided by 4 into n factorial minus n plus 3, n plus 2, n plus 1 upon n plus 1 factorial is there, which can be written as n plus 1 into n factorial. So n plus 3 p3 is nothing but was a short form of writing n plus 3 p3. Write 3 factors starting from n plus 3 in reducing order. If you have 3, write 3 factors. If you have 2, write only 2 consecutive factors. For example, if you have 9p2, you write it as 9 into 8. If you have 9p3, you write it as 9 into 8 into 7, like this. You know that. So after writing this, what will you get here? You're getting it as something n plus 1 is getting cancelled here, and what you get here is n factorial as LCM, 4 into n factorial as LCM, and numerator is 195 minus of n square plus 3n plus 2n plus 5n plus 6. Okay, now if you simplify this, what you get here is nothing but 195 minus x is nothing but 189 minus n square. Of course, you are getting 4 also here after taking LCM. So minus 24. 195 minus 24 is how much? 195 minus 24 is nothing but 170. 171, isn't it? 170. Okay, let us see that. Now minus 4n square minus 20n divided by 4 into n factorial. This is what we have got. In the numerator. 195 minus 24, 171 minus 4n square minus 20n divided by 4 into n factorial. What is that? Xn. Now what do we want? We want the positive terms in the expansion. Means it must be greater than 0. That is what your understanding must be. It should be greater than 0. So let us see when it becomes greater than 0. So don't forget that you have n is greater than or equal to minus 1, which we have concluded in the beginning itself. Here what do you understand? 171 minus 4n square minus 20n should be greater than 0, because we need positive terms here. The denominator, you can neglect it, it's always positive. N factor is always positive. Now if you multiply with minus, it is 4n square plus 20n minus 171 less than 0. 171 less than 0. Is it correct or not? Let us check it out. 195 minus 24 is minus 25. 171 plus 24 is correct only. So now if you see this one, what happens? Is it divisible by any number? No. So in such a case, you do like this. Write the factors, write the quadratic formula. Minus b plus or minus root over b square minus 4ac 16 into 171 by 8. Okay. So it is now, let us keep this in consideration, n is greater than or equal to minus 1. Now from this one you will understand minus 20, n is greater than or equal to minus 1. Let us keep that in consideration. It is minus 20 plus or minus root over 400 plus e square minus 4ac. 4 into 4, 16 into 171. This is 2a. 2 into 4. Correct one. Minus 20 plus or minus root over 400 plus ones. This is 16 ones are 16 and 16 sevens. You take it 16 sevens or 42. 16 7. 2736 divided by 8. It is minus 20 plus or minus root over. It is 6, 3, 11 and 3136 divided by 8. It is minus 20 plus or minus root over 3136 is approximate. Let us write the approximate value for this, because 2500 is 50. Under root 2500 is 50. Under root 3600 is 60. So it lies between 50 and 60. It lies between 50 and 60. Let us take the approximate value and divide it by 8. Then what you're getting, it's little complicated problem, because in the simplification part you will have the complicated factors like this. So complicated factors, it is 56. It is 56. So if you see this one now, what are the roots you are getting here? Minus 20 minus 56 minus 76 minus 76 upon 8 minus 20 plus 56 minus 20 plus 56 46 36 by 8. These are the roots. Now why we are getting these roots? We want to factorize this now. This is to be factorized. So what is its value approximately? Minus 9 point and 36 by 8 is nothing but 4 point. It is 4.5. These are the values we have got for this quadratic. Understand that first. These are the values we have got for this quadratic. Now this quadratic now can be written as, this is all, you know, it's a procedure, and this can now be written as what? N minus 4.5 into n plus 9.5 less than 0. This is what you have to understand. Now if you write this as 45 by 2, 45 by 10 and 95 by 10, then if you form the equation, you'll get the same now. So from this one, what do you get here? Here n belongs to, less than 0 is there, n belongs to minus 9.5 to 4.5. This is what your understanding must be. N belongs to minus 9.5 to 4.5. But we have already in the beginning, we have taken, but n is greater than minus 1. You must take. N is greater than minus 1 means all the values below this will be neglected. So all the values below minus 1 are to be neglected. Only the values that are greater than minus 1 are to be taken up to 4.5. What are they? Greater than minus 1 means you have to take n is equal to 0, 1, 2, 3, 4. Up to 4.5 you have to take. If you put n equal to 0, whether it satisfies or not, you have to see that one. So from that one you can conclude the number of positive terms by substituting these values. So this is a little lengthy problem, but logical problem because you have algebra involved in it. So through the simplification of this one, you can understand whether it has positive terms or not. So for these values of n, whether all are getting positive values or not, you can check it out. Substitute 0, 1, 2, 3, 4 and you can check the answer like that. Okay. So this is mostly involved in this problem. The most of the part is involved with algebra other than permutation combination, because in permutation combination only the formula is used only to write n plus 3 p3. Okay. Let's go through the next one now. Next one is the number of ways in which the candidates A1, A2, so on A10 can be ranked. A1, A2, A3, so on A10 can be ranked if A1 is always above A2. If A1 is always above A2 is. Always remember, whenever 10 candidates are there, they can be arranged in 10 factorial different ways. Simple logic. They can be arranged in 10 factorial different ways, but it is given that A1 is always above A2. A1 is always above A2 means there are two cases here. A1 is always above A2 means A1 is not immediately above A2. A1 is not immediately above A2. Like A1, A2 is like this. A1 is above like this. A2 is like this. In between, some other persons may be there, then A1 may be here. A2 is here, in between, whoever may be there, A1 may be here. That means the context is here, it may be immediately above A2, may not be immediately above A2. That means it must be anywhere. So in such a case, what you have to do, simply you should not consider the order of these two persons. You should not consider the order of these two persons. How many persons here restricted? Here A1, A2 are restricted. The simple logic and simple answer for this one is 10 factorial upon 2 factorial. 10 factorial upon 2 factorial. I'll explain you more general way like this for your understanding, better understanding. There are n different things. N different things. On order of r different things. Of course, r is less than n. Is not to be considered. Then number of arrangements or permutations, number of arrangements or permutations is equal to n factorial upon r factorial. Remember this, please. It's an important formula which you do not get the flash of this formula immediately while solving the problems related to this formula. What is it? There are n different things and order of r different things is not to be considered. Then number of permutations is equal to n factorial upon r factorial. Why do we divide NPR with r factorial to get NCR? The logic is when r things are chosen for arrangement in permutation, the order of r things will also be considered in a permutation, which is not necessary for a combination. That is why we divide with r factorial. Here also the same logic. There are n different things and order of r different things not to be considered, and hence we have to divide n factorial with r factorial by taking all at a time. The same is the case here also. A1, A2, A3, so on, A10 or different the number of ways in which candidates A1, A2, A3, so on, A10 can be ranked. If A1 is always above A2, then in such a case what is to be done? Arrange all of them first, 10 factorial. And how many persons has restrictions? 2 persons has restriction. So that is why it is simply 10 factorial divided by 2 factorial. That's all. 10 factorial divided by 2 factorial is the answer. If 3 persons are there such, then it will be 10 factorial divided by 3 factorial. Understand that. So you can check it out. The fourth option is half into 10 factorial. This 10 factorial with 2 factorial value is 2 only. That's the option. Okay. So if it is given that they must be immediately done, then we'll pack them and we will arrange them with the remaining things. That case will come again. We will discuss then. Okay. Let's go to the next one. There are n white and n black balls marked 1, 2, 3, so on n. How many white balls? How many black balls are there? N white balls are there, n black balls are there. Mark 1, 2, 3, so on, and what does it mean? By marking what happens? By marking what happens, even though balls are of the same size, because the numbers are given to the balls, you have to treat them different now. So you must understand that problem like this. There are n dissimilar white balls, okay, and you have n dissimilar black balls. Why dissimilar? Because the numbers are given very much. 1, 2, 3, so on, n numbers are given. So in the problem, there are n dissimilar white balls, n dissimilar black balls. The number of ways in which we can arrange these balls in a row so that neighboring balls are of different colors. Is. Now you can straight away compare this problem with n boys and n girls. You can straight away compare this problem with n boys and n girls. Let me start like this. Let me compare this with n boys and n girls. If you have n boys and n girls to be arranged in such a way that no 2 boys to sit together, or in this question, so the neighboring balls are of different color. There should not be 2 girls together, or there should not be 2 boys together, or we can say simply it is to be mentioned like this: the boys and girls sit alternatively. And boys are there, and girls are there. They are to be arranged alternatively. What does it mean? Let me take B1, boy 1. Then the row may start with boy, or the row may start with a girl. Need not be B1, G1. Just for example sake, I have taken like this. If the row start with boy, that becomes one type of arrangement. If the row starts with girl, that becomes another type of arrangement. In this one, BG, 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 and so on. BG will be there. In this one, GB, 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 and so on, GB will be there. Do you understand what I'm saying? Now, in this case, what happens? How many boys are there? Whatever the arrangement we did, you have to arrange this in such a way that there must be only internal arrangement among the boys, either among the boys or among the girls. Like how many boys are there? N boys are there. They can be arranged among themselves in n factorial different ways. And the girls among themselves can be arranged in n factorial different ways. So n factorial into n factorial. First operation, second operation. Do you understand this? In this type of arrangement, the arrangement starts with boy. In the second type of arrangement, the arrangement starts with a girl. Here also the same logic, that is, girls among themselves can be arranged in n factorial different ways and boys among themselves can be arranged in n factorial different ways. So total number of arrangements are, first one is n factorial whole square, second one also n factorial whole square, added together twice of n factorial whole square. So understand, simple. There are n boys and n girls that are to be arranged in a row in such a way that the boys and girls sit alternatively. The boys and girls sit alternatively. Then the arrangement may start with a boy, the arrangement may start with a girl. Then these can be, the boys among themselves can be arranged in n factorial ways, girls among themselves can be arranged in n factorial ways. Similarly, if it starts with a girl, it is also similar. So n factorial whole square plus n factorial whole square is nothing but twice of n factorial whole square is the number of arrangements of n boys and n girls such that they sit alternatively. What makes the similarity? What makes the similarity between this and that problem? If you go to that problem, there are n white and n black balls marked 1, 2, 3, so on n. If they are not marked with 1, 2, 3, so on n, if they are similar balls, the case becomes different. But here, because the numbers are given, they will become like n different balls, n different girls, like that. So here in this case, it may start with a white ball, and next will be black ball. WB, 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 so on, WB. And here, BW, 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 black, white, so on, black, white. So what happens? The same, similar. So the answer is here, in this case, twice of n factorial whole square. So understand the similarities of such problems so that while solving the problems, you'll feel that easiness. Okay, let's go to the next question. In a class of 10 students, there are 3 girls, A, B, C, capital A, capital B, capital C. The number of different ways that they can be arranged in a row such that no 2 of 3 girls are consecutive. No 2 of 3 girls are consecutive. What does it mean? First of all, remember a very important point in solving permutations and combination problem is that while solving any problem related to permutations and combinations, don't forget that first of all, you have to fulfill the restriction given there. You have to fulfill the restriction given there. What is the restriction in this problem? In a class of 10 students, there are 3 girl students, and the restriction is all these 10 students are to be arranged in such a way that no 2 girls must sit together. That means between 2 girls there must be at least 1 boy. Between 2 girls there must be at least 1 boy. So how many boys are there here? How many boys are there? Number of boys are 7. How many girls are there? 3. So because there is restriction for girls here, we don't touch it first, and we are now looking for the number of places among the boys for the girls to be arranged. How many boys are there totally? 7 boys are there. 7 boys, 1, 2, 3, 4, 5, 6, 7. Now I am counting the number of places among the boys for the 3 girls to be seated. So the places will be 1, 2, 3, 4, 5, 6, 7, 8. If I place girls in any one of these 8 places, I'll take one girl, and if I make her to sit in any one of 8 places, and if I take the second girl and if I make that girl to sit in any one of these places, then definitely no 2 girls will be together. Definitely no 2 girls will be together. So first of all, let us arrange these 3 girls in these 8 places. It can be done in how many different ways? 8p3 different ways. Restriction fulfilled. Restriction fulfilled. What is 8p3? This is 3 girls are there and 8 places are there. 3 girls in 8 places can be filled in 8p3 different ways, and the boys among themselves can be arranged in how many different ways? Because it is a linear permutation, it is 7 factorial. First operation, fundamental principle, fundamental theorem. I didn't mention that in the beginning because you all know that. Fundamental theorem is if an operation can be performed in m different ways independently, second operation can be performed in n different ways independently, then these 2 operations, one after the other or simultaneously, can be performed in m into n different ways. So first operation can be performed in 8p3 different ways. Second operation can be performed in 7 factorial different ways. These 2 operations together or one after the other can be performed in 8p3 into 7 factorial different ways. So what is 8p3? 8 factorial upon 5 factorial into 7 factorial. This is what the answer must be. So you can see that 7 factorial into 8 factorial upon 5 factorial is the answer for this. Okay, so what is the learning in this problem? The learning is, first of all, always fulfill the restriction given and then operate the remaining things. So while solving any problem related to permutation and combinations, try to fulfill the restriction first, then only perform the remaining operations. Let's go to the next one now. The number of positive integers that can be formed by using any number of digits, from 0, 1, 2, 3, 4, 5, but using each digit not more than once in each number is dash. The number of these integers that are greater than 3000 is. The second part you can do that. Let us see the first part. The number of positive integers that can be formed by using any number of digits from 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, but using each digit not more than once in each number. Positive integer which can be formed by using any number of digits. The positive integers means number of digits in the integers not mentioned. So you have to write 1-digit number, you have to write 2-digit numbers, you have to write 3-digit numbers, you have to write 4-digit numbers, and even you have to write 5-digit numbers, 6-digit numbers, because totally you have 6 digits here. So 1-digit numbers, positive numbers means you take a blank place, 1-digit. 0 is not needed because we need positive integer. So there will be only 5 chances to fill 1 or 2 or 3 or 4 or 5. It can be done in 5 different ways. And 2-digit means you should not have 0 here, because if it starts with 0, that becomes 1-digit number. So how many are here? 5 are here. 5 are here because 1 digit is already filled here and you can fill 0 here. So 0 will be included here. It is 5 only. Do you understand what I'm saying here? Because 2-digit numbers should not start with 0. If it starts with 0, that becomes 1-digit number. So excluding 0, what I did, I filled the first blank place with any one of these 5 digits in 5 different ways, because it is to be used only once. And because 1 digit is already filled here, you can use 0 here. 0 here. Now 1 digit, let us suppose 1 is filled here, let us suppose. So how many are remaining? 5 are remaining. So it is 5 into 5, it is 25. Next 3-digit numbers, similarly, 3-digit numbers. 0 should not be there. 0 should not be there. Then what should it be? Then how many are there? 5 are there. 0 included now. 5 again. Now 2 digits already filling. So 4 will be there. So 5 into 5 into 4. It is nothing but 100. It is nothing but 100. Similarly, 4-digit number. Now you can say 4-digit number. It is 0 should not be there. 5 into 5 into 4 into 3. What should it be now? It is 2500, 300. It is 300. Similarly, 5-digit. 5-digit number, 0 should not be there, and 5, and again it is 5, 4, 3, 2. 100 into 6, 600. 6-digit number, you practice like this. 0 should not be there, because if 0 is there, it becomes a 5-digit number. So 0 should not be filled. How many are there now? 5 are there. 0 included here. 0 included here. So again 5, 4, 3, 2, 1 like this. Now it is 25 into 400, 100 into 6, 600. Now you have to add this to get the total number of numbers. 1200, 1500, 1600, 1600 and 30 should be your number of positive integers. 1630 should be your number of positive integers. So I have shown this one for a better understanding, and in this type of problems don't use the formula NPR. Generally you go with the fundamental principle, fundamental theorem. Otherwise, how you think more practically. For 1-digit number, only 1 blank place, 5 digits, so 5 ways. 2-digit number, 2 blank places. But in these 2 blank places, it should not start with 0. That is with 0 avoided here. 0 avoided here, and only 5 are taken. But how many then remain? 4 remain, but 0 will be included in this case, because you can fill 0 here. That is a 4 plus 1, 5. 5 into 5 like that. Similarly, 5 into 5 into 4, 5 into 5 into 4 into 3, 5 into 5 into 4 into 3 into 2, 5 into 5 into 4 into 3 into 2 into 1. You may be taught in a different way also, like we first fill this in this way. 2 blank places are there. 2 blank places are there. 2 blank places can be filled with 6 digits in how many different ways? 6p2 different ways. But among them what happens? Some of the digits start with 0. So we fill 0. And how many blank places will be remaining? 1 blank place will be remaining. And how many digits will be remaining? 5 will be remaining. So minus 5p1 we write. Check it out what happens. Check it out what happens. 6 into 5, 6p2. 6p2 is nothing but 6 into 5, 30. 6 into 5, 30 minus 5 is 25. After writing this and simplifying, instead you write it directly like this. That will be more comfortable to you instead of using the formula. Okay, so the result you will get directly if you arrange like this. So the number of positive in numbers that can be formed using the digits 0, 1, 2, 3, 4, 5. When each digit is used once, then it's number 1630. And if you want more than 3000 in the second blank place, the number of these integers that are greater than 3000. That are greater than 3000 means you have to fill the first blank place. That is, you need greater than 3000. Greater than 3000 means it must start with 4-digit number. That means this will not be there. This part is to be taken. And in this part only you must have 3 here. You should not have 0, 1, 2. You should not have 0, 1, 2. But you must have either 3 or 4 or 5. That means here you will have 3. Here you will have 3. and remaining you can arrange like that. Here there is no restriction, the same number continues, like that you can solve the problem. So the only alteration will be this part will not be there, because what we need is greater than 3000. What we need is greater than 3000. So in this, please, for a better understanding, I'll tell you like this: 3 or 4 or 5. So this becomes 3 now. One is filled. And what happens? 5 4s 20 into 6. 20 into 6 is how much? 120. 20 into 6, 120. Now if you add this, this will be how much? 12, 13, 20. 13, it should be 1320 must be the answer. Check it out, please. 0, 3, 4, 5. It can be filled in only 3 ways, and this can be filled in how many different ways? Let us say you can. That's what the change is. Here 6 digits are there. 1 digit already used. 5. Correct. It is 4. It is 3. So it is 20 into 6. 120. 20 into 6. 20 into 9. Okay. 180. So it is 1380. So that's option there. So 1630 1380. It is greater than 3000 like this. Okay. Let's go through the next one now. The total number of numbers from 1000 to double line, both inclusive, that do not have 4 different digits. Do not have 4 different digits means what? You must have at least 1 digit repeated.